Might also know us as Team Spicy Weasel, so we try to get to DerbyCon every year as a team, and we sort of do the CTF, so some pretty good write-ups there if you're interested, but you might have seen us there. So let's get to the crux of the talk. So what is PowerShell, and is it dead? So I think a lot of the InfoSec community sort of are starting to say the term PowerShell's dead, don't use it anymore, but I think we need to think about it a little bit more. I think we need to go into the crux of PowerShell and what it actually is. So when people say, oh, PowerShell is dead from a defensive perspective, does that mean sort of threat actors, aren't using it anymore? You're not allowed to, you can't use it, it gets detected or it's blocked. But are they referring to the PowerShell, the Microsoft signed binary? Is that what is blocked? So if you're caught running PowerShell.exe in a box, it'll be one blocked. If it's not blocked, it'll be detected instantly. Is that what we're saying when we say PowerShell is dead? Is it the DLL behind the binary? So actually PowerShell.exe is just a wrapper for the System.Management.Automation.dll. So if you've got good products like EDR, which has tracing enabled and allows you to see all the DLLs loaded, is it the fact that if you run any System Management Automation DLL or any process on a box, now that's capable of being detected? So that is actually what we say when we say PowerShell is dead. It's both the exe and the automation DLL. Or is it typically the folder? It could be the folder that PowerShell is launched from. So if we go and copy PowerShell.exe to another folder within Windows and have a different name, does that mean we can actually use that? And that isn't blocked. So we need to sort of understand what people say when they say PowerShell is dead. Also, I don't know if you're aware or not, but since version 4 and 5, it's now got integration within AMSI, so you can see things at signature level from an AV perspective. It's got things like transcript logging, script logging, and module logging. So anything that's kind of run within the PowerShell run space, whether that be from the .NET Management Automation or directly from PowerShell, you've got a chance to detect it and see it. So if we're running common tools like PowerView and PowerUp and things like that, with the likes of script logging and transcript logging, you now from a detection perspective can see that within the transcript and have a chance to see people early. So we talk a little bit more about the crux of PowerShell in our other talk, but we kind of tried to mix it up a little bit. So if you want to go see the talk, it's there. Cooper's put it up online. So it gives you a little bit more background about PowerShell before than we do in this talk. So which moves us on, I guess, to the evolution of POSH-C2. So if those of you who don't know what POSH-C2 is, it's a PowerShell framework completely written in PowerShell, or at least it was to start with. So both the C2 server side and the Implant side was written in PowerShell. So you just have to have a Windows box. You can deploy it on a Windows box, whether that's in the client environment or not, either through the internet or not as well. The Implant just runs purely in PowerShell. Originally, it was literally anything you'd have to run is a PowerShell one-liner. So it would have the -e encoded command with a massive blob of base64 text. We then went through some iterations of changes. We implemented a C# GUI, which allowed you to do things like right-click get system and right-click get screenshot, but absolutely hated it as an operator level. People like Doug and myself and Rob, when you're using it, you want to know what you're typing in and you want to get the output back instantly. You don't have to be waiting for something to happen in a GUI, so kind of scrap that pretty quickly. We've introduced the POSH-C2 Slack channel so people can get on there and sort of put any help or any problems that they're having or running any tools. We actually ported the server over to Python as well to make it sort of cross-platform, so you can now run it on Linux or Unix-flavored systems, even Macs, from the server side. And one thing that we did was, which made a massive difference, was the reflective DLL or the shell code. So this was based off the good work that Stephen Fewer did to allow you to load the managed runtime CLR in unmanaged code space. So now you can port any implant from PowerShell one-liners now going into any process on an operating system. So things like SVC host, things like Search Protocol Host, Outlook, any process that's running as your user or your user level, you can now migrate into that and be running all the same commands that you were before. So that was kind of a big thing. Also, Rob, who's here again today, he released SharpSock, so it's kind of one of its kind outside of things like Metasploit and Cobalt, which allows you to now use all your tools server side, tools like Nmap, Telnet, RDP, so MSTSC. You can now tunnel that over HTTPS beacons, and it will be relay at the other side of the implant. So you can just RDP to servers all through HTTPS beacons. So it allows you to be much more flexible. And this is all integrated within SharpSock in version 3 of POSH. We then did some other things, actually wrote some documentation, which is great. Made it a lot easier for people outside of NetSuite to use. And also in 2019, or sort of around the Christmas time, we released a Sharp implant. So this is actually now moves completely away from either the PowerShell.exe or the System.Management.Automation.dll. So we've now got fully fledged implants that don't have either of those in. And we'll talk a little bit about that in a little bit of time. We also added support for 2003 and XP. And when I say support, it more means that the sharp implant actually just works on that by default if they've got the .NET Runtime version 4, which they can have if it's the latest versions of both those operating systems. You might say, why the hell would you backport it to 2003? Well, some of our clients and even some of the big clients still have 2003 legacy systems running in their network. So you'll be amazed how many times you see that. And it's actually quite difficult these days to get your tooling to work on operating systems such as XP and 2003. And in June, Rob's made some massive updates recently, not pushed them yet, so watch this space, but SharpSox has got like uber quicker than it has before, and the integration within Posh is going to be almost, you start SharpSox and it'll just instantly start, it'll do all the server stuff on the back end, and it's all going to be written in .NET Core. I don't want to steal his thunder, but that's kind of a lot of stuff that we're going to be doing and hopefully releasing in June if he pulls his finger out. So this is what PowerShell used to look like. Posh 2 used to look like when it first came out, all written in PowerShell. From an offset consideration, from a defensive side, this is what it would look like. You would go on a box, see if it's compromised, PowerShell would be running. You dig a little bit deeper, you would see there'd be a massive blob of base 64. You could go and decode that base 64. You could see where all the CT URLs are. You could see where the encryption keys were. You could decode all the traffic. Very, very simple to sort of debug from that side from a detection perspective. Especially with the integration of EDR, so when Carbon Black and Tanium and likes have been coming across, you can really easily threat hunt your estate and go, okay, show me everywhere where PowerShell is running, and you'll be able to go and see the command line options. And so if someone is using Posh 2 in your estate and you've got EDR, on the PowerShell level, really, really easy to see. So that's kind of where Posh 2 started. Even when you added the reflective DLL and the shellcode, it's now just as simple with the likes of EDR, Carbon Black and Tanium, to find out where they've loaded the System.Management.Automation.dll. So which processes. So as you can see here, sort of like NetSH, Search Protocol Host, SVC Host, all of these are actually bad malicious processes that we've started and put the implant in. So again, this is another great way to threat hunt your estate to go and see where other people have done this. It's very unlikely that processes other than PowerShell and a few other processes that use similar versions of PowerShell that have system management automation and that aren't malicious. So another great way to find PowerShell within your environment. So I guess from a defensive and legacy approach to PowerShell, so back in the day everyone was just like, well, let's just block PowerShell, let's get rid of it, let's put some sort of blacklist in place and stop PowerShell running on endpoints. But I guess that didn't really cut it. So the modern approach and the proactive approach is actually to allow it. So things like version 5 has much greater visibility, like I was talking to you about, like the transcript log, and you can see everything that's in that run space. You can enable constrained mode, so even has language restrictions, a bit like Add-Type, so you can't just compile your own stuff on the fly. You can monitor for things like the System.Management.Automation.dll in the process. Most vendors, I think pretty much all vendors now, or all the bigger vendors, have AMSI integration. So a lot of people used PowerShell before to get code directly into memory so that it couldn't be scanned. Well, a lot of them now have AMSI integration so they can see all the commandlets before they go into memory. Script log, transcript log, and a module log. And again, this is all great for showing early signs of suspicious behavior on your network. So I guess what this comes back to is, from our perspective, is PowerShell dead? So if you take all the things I've just said into account, it's all based off what you have from a defensive perspective. So if you're going into an environment that isn't running any EDR and just running simple logging on an endpoint, PowerShell is absolutely fine. PowerShell will be running no problem at all. You won't have any logging, any alerts. Even most AVs, some PowerShell one-liners still get around. So in our opinion, no, it's not dead. It is purely dependent on the configuration of the endpoints and the configuration of the client. So with EDR, it's definitely getting more difficult. But you can still run System.Management.Automation on most large EDR rollouts nowadays. Because a lot of them have to have things like the tracing enable, which takes a lot more processing power. So again, it's usability versus security. So it's all down to configuration, which is key. And if you didn't believe us, APT33, according to Fire, I've been using it basically in the whole of 2018 to hack the aerospace and energy sector. So some really good write-ups there. And they haven't been doing anything clever. They've been throwing HCAs in via sort of random emails, basically getting HDAs to pop and running PowerShell. Literally PowerShell one-liners. They haven't been even using the sort of system management run spaces. They've just literally been doing one-liners, and they've been getting away with it and having some really good success from these blogs' perspectives. So if you did still think PowerShell was dead, I'm just going to introduce the C# implant. So we released this in December, sort of January time this year. Same way as before. So when you start Posh 2, you get basically two options. The way to deploy it via shellcode, so you can deploy it however you want to deploy shellcode, any shellcode cradle, or you can just pop a DLL onto disk if you want to. So in the simplest form, I'm just going to show you how you can get it going. So basically just chuck the DLL on disk. If you don't know the entry point, it's all written in the documentation, or should be, but if you don't, open CFF Explorer, check the exports, and you can see which entry points. You can modify the entry points, but this one just void func for simple. And then you can do things like migrate, as you could before. So once you've migrated with a C# implant, what does that look like from a defensive perspective? So let's just take a simple 64-bit process, search protocol host running on a Windows system, but this is actually PowerShell, the Sharp implant running POSH-C2. So what you wouldn't normally see is the .NET assembly. So no search protocol host on your system across your estate should ever have a .NET assembly or .NET runtime loaded into it. As you can see here, it's got a new app domain. The app domain's got a randomly generated string. Inside the app domain, as you can see, there's two assemblies. Both those assemblies don't have a location on disk. That is always a point that something looks not quite right, and it should go and be searching for these kind of things. Other things that you might notice as well is it's loaded the CLR.dll or the MSCoreEE.dll. So both of these are a requirement to run, basically, the CLR within runtime, within unmanaged space. So as before, I guess the OPSEC consideration would be the System.Management.Automation.dll. Now it's the CLR.dll or the MSCoreEE.dll. But a lot of other systems, even like Cylance, I think, are written in .NET. So there's a lot of other programs out there across your estate now which will be using CLR.dll. So it's not quite as simple to do the same thing that we were talking about before with Tanium and things like that, to do show me everything that's got the System.Management.Automation, because CLR is running a lot of programs, even a lot of Microsoft programs that are typically used on a day-to-day basis. One thing to take a note of is within the Sharp implant is the help. So typically the PowerShell implant, which is basically a command prompt, has all the features of like change directory, copy file, delete file. When we introduced the C# implant, none of this is default. So we had to actually recreate just a lot of the common features that you would typically want to use, literally like change directory. That doesn't exist. So we have to actually write the code behind that. So we've done a lot of work on the core DLL, or Rob has also done a lot of work on the core DLL written in C#, but it doesn't have everything. So what we've actually done is given you the cradle to load any C# assembly within your own run space. So take Seatbelt, take all the great work, that Spectrops have done with GhostPack, etc., loads of other programs like that. You can basically take any of those binaries, compile them yourself. I wouldn't ever take any binaries off the internet and run them. And either you can run a DLL or run an XE. They're the kind of two main features. So you can go write all your own modules, all your own core DLLs, and run them through this harness. So all you have to take a note of is, if you're running a DLL, the main difference, I guess, between a DLL and an XE is the entry point. So an XE should have a main or should have a main method, whereas a DLL wouldn't, so you have to specify that as a parameter. So as long as you know the class name, so for example, seatbelt, the class name is program, but the namespace is seatbelt, so the namespace plus the class, and then the method, and then you can run something like user checks, happy days, through the implant. As long as it runs to console.writeline, then we all hook that information and bring that back to you through the implant. So that's quite simple it is to run something like that within POSH-C2, almost like the execute assembly within Cobalt Strike. Just digging a little deeper, I won't go too much into the code, but for those of you who do know some .NET reflection stuff, this is how basically we're doing it under the hood. We're going through, looking through all of the assemblies that we've loaded on disk. So if we've loaded Sharp, Seatbelt, whatever it is we've loaded, basically with the run XE, we're picking the entry point and invoking it with certain arguments, whatever you pass. And with the DLL, basically, we're passing it the method name plus the parameters as well. And then we're just capturing the output. But this just allows you to run anything. So although there's probably not as fully fledged as the PowerShell implant, all the coding and also all the scripts behind it, this does allow you to go and write your own code and just deploy it quite quickly within any C# implant. Again, from a defensive perspective, let's just take a quick look what that looks like though. So again, you see the app domain, but also you'll see the XEs. So you want to be mindful when you're compiling your own XEs what you call them. So things like seatbelt will then stick out like a sore thumb, and people are actually looking for this in the app load or this sort of load assembly modules. Then obviously seatbelt's probably not a good one going forward from a signature perspective. So make sure you compile them and call the namespaces something different when you roll them out. So I guess this is pretty much it from a C# perspective, but I guess it's hopefully helping get around other things like EDR. But if you want more information on that, I think Doug's going to talk quite a bit about EDR and sort of next-gen AV now and go into a bit more detail about how we get around that.
Warm it. Sorry. Thanks, Ben. So, obviously, up to this point, Ben's mentioned EDR a lot, but who actually knows what EDR is? Endpoint detection and response software. So, it's basically behavioral data, and it's sending all that behavioral data through an agent back to a central database, and then it's doing its analysis there. So it's not just static signatures, it's not just looking at one thing, it's able to pick up lots of things, it's able to put together big process trees and pick them apart. If you think about a Word document with a macro, that's going to kick off VBA, that's going to possibly do W script, it's going to download a file, it's going to execute that, that can all be tracked in a chain. And that's the kind of power that EDR gives, it's that extra visibility that wasn't there before. Some of the vendors you'll know, Carbon Black, Cylance, Sentinel-1. Before endpoint detection and response was really a thing and it was there, it was very much so head in the sand for the blue team. They had not too much visibility. Now it's a bit of a role reversal. It is a bit of a game changer when I'm doing my red teams and I get in and I'm doing a situation awareness, run process listing and see something like Carbon Black or the other. It's very much so do not want. I was hoping for a bit of an easy gig this time, but unfortunately I'm now going to have to be really careful with what I'm actually doing. But it's not, while it is a game changer, it's not completely everything. We're still plenty of room to play in and you just got to be really careful. So a couple of thoughts. We're going to go through avoidance, trickery, and parting with EDR. In the end, as it's there, we're going to have to share the dance floor with EDR. So avoidance is, as you'd expect, it pretty much is try to work out what EDR's doing and don't do it. Don't get detected. An example of this, and sadly it came from a detection. We got detected, and we actually buy in a lot of the EDR products and start to research them and look at them and what they do. But before we did that, we actually went online and had a look to see what certain EDRs were doing. So the one that caught me was Carbon Black. We went a look, had a look. When you're installing it, there's a lot of feeds out there that you can pull in. So Bit9 Suspicious Indicators is one of them. It's got MITRE feeds that go into it now as well, and that ends up being all the signatures that come back from the centralized database. So it was a bit of an RTFM moment from myself. If you actually dig into those and you start to see what they're doing, suspicious process execution, suspicious SVC host parent, well, we were using SVC host as a parent and then executing things underneath that, like PowerShell, like any of the scripts that you've got, it's doing CSC to compile code on the fly. That's all very suspicious. Also setting files as hidden in system seems like a really good idea, but not if you know that that's what EDR is watching for. So avoidance, stop. Figure out what it's doing and then don't do it. Another example, Ben kind of touched on this one. If you can look through your whole estate and you can find all the binaries that are running System.Management.Automation.dll, then you'll find this signature here from Tanium tries to do that, and it says, not in these binaries, these are the binaries that it's expecting to find it in. So someone's attempted to put this signature together, but they've actually made a mistake, and that is that they're not actually doing any checksums on the actual binaries at all. They're not verifying those are the right ones. They're not even checking the process path. So I can now take one of the Posh executables, drop it onto the desktop, call it monitoring host.exe with System.Management Automation inside it, and that won't flag. Not on that alert anyway. Trickery. This is kind of, so if you think about that process tree that the blue team can get, and you know they've got that visibility, it's trying to trick that into not being able to show exactly what you're doing at a time. So there are certain things that have been about for a long time, like parent spoofing. DJ Stevens was talking about this in 2009. It's pretty much in every main C2 now as well. But the code for it is actually, this is just off Stack Overflow to show you what it looks like. You've got a startup info X, which is a structure with IP attributes list, and then you can update the parent head inside that, just here. What that allows you to do is basically just say, Explorer is my parent. So if you think about that attack path when you're doing this, again, if you're in a macro and you're executing something previously, that would have been your parent. Microsoft Word might have been your parent. But now you can actually say Explorer is my parent. And when you think about how someone uses an operating system, they generally launch things from Explorer, not from inside a Word document. So it's helping you bypass and possibly bypass some of the detections. Parent PID spoofing. This is what it looks like specifically in Carbon Black. So POSH-C2 has the capability for parent PID spoofing. We've said 6.2.5.2 here. And then inside Carbon Black, what we've got is Explorer launching SVC host. So that is just using the same Stack Overflow code inside a DLL to carry this out. But just proving that it does actually work and does bypass things like Carbon Black. Detecting parent spoofing, Counterset brought out a blog post about 6 months ago. And using event tracing for Windows. So in event tracing for Windows events, you've got a header field which contains the process ID of the process that's kicked off an event. Inside that, you've then got the data of the event. And you'll see here, just parent process ID 9224. And then in the header, you've got process ID 9224. That's what it should look like. But if you do parent process spoofing, PID spoofing, you've got 4652 as the parent process here, but it was actually launched by process ID 9224. Therefore, you can say that's a detection. You've just identified parent PID spoofing. Process argument spoofing, something that came out in Cobalt Strike just recently with the argue command. Anybody familiar with this? A couple of people. Basically, every process I should actually mention as well, because I always forget to call people out when they've done something, but Will Berg has done a talk, Red Teaming in EDR Age. It's a really good talk, you should go check it out. It covers process argument spoofing as well. But inside each process, it has a PEB, a process environment block, which tells you a lot about the process. And it's a structure much like this here. Inside that structure, we've got RTL user process parameters, and inside that you've got command line arguments. So you can actually go look through the memory, use the structure to parse that and identify where your command line arguments are in your process. This is important because we can use and abuse this as attackers. So if we create a process suspended with fake arguments, so you can create whatever you want, a PowerShell one-liner, for example, not that I'd endorse that necessarily, but identify the PEB using NT query process information. Then we are going to parse the PEB with the structures to find out where the command line structure is. We're then going to overwrite the command line structure using write process memory and then resume it. What actually happens when that's happening is the Windows and a lot of programs inside Windows will actually take the event, a snapshot of the event at the time in which it's been created. So that's when it's suspended. So the fake arguments exist there, not the real arguments, which is what it's going to look like when it runs. So there's multiple tooling out there that actually do this, as I mentioned, argue inside Cobalt Strike. Swamp Thing was a really cool tool FuzzySec put together. And I just wanted to give you some code that you could actually go look at to see how this is done specifically. But in this example, we're going to use Swamp Thing to launch command prompts. We're going to give it fake arguments of echo hello sailor and real arguments of echo hello B-sides. What we see here is actually it's echoed hello B-sides because that's the real arguments and that's what we wanted it to do. So that's what we've carried out. If we actually look at process hacker and look at the command line, it actually says hello sailor. So we can start to throw off the blue team with their own tooling. And if you think about how we're going to use that, you can use it for execution, potentially bypassing some of the detections you've got around execution, or lateral movement, probably a better one. If you're going to move to one host but make it look like you move to another, then the blue team will be looking at this other host while you're on this host doing what you want. There's quite a lot of good things you can do with that and nice plays. Parting with EDR. EDR is not going to go away. It's on a system. It just seems to be getting installed on more and more systems these days as well, but it runs the system as well. So it has more power than you generally on an endpoint when you get there. So you're going to have to share the dance floor with EDR. But to talk about how EDR and what it's actually doing, so some of the attacker methodologies to migrate processes. There's many reasons why you do that. But I just want to cover over some of the API calls that you would do to do it, and then we'll look at how EDR is going to defend against that type of thing. So migration basics, we'll take a handle on another process, we'll then allocate memory in this other process using virtual alloc X. We're then going to write our shellcode in using write process memory, and then we're going to create remote thread on that, and that's going to kick off our implant inside another process, running as a single thread. So again, pointing out a tool, inject all things. It's got a lot of different API calls inside that show you how to build up some of the migration techniques. However, there's many things you can actually use migration techniques. So create remote threads one, and in certain cases EDR has detected that. But actually RTL create user thread is another that does exactly the same thing that wasn't detected by specific EDRs. So we were actually able to bypass some of the EDRs just by using different API calls. How does this actually work? And this is my diagram. I put this together. It's probably not 100% accurate, but it's how I see the world. So you basically got your process, which is going to call virtual alloc X, which is then in turn going to call ZW allocate virtual memory. And that's actually the call that makes the syscalls over to the kernel. So that's where it actually happens. And EDR is going to try to intercept that, and it's going to intercept that by doing a thing called hooking. And in short, hooking is a technique that allows you to alter or augment the behavior of an operating system. If you think about old school gaming, when you could hook the game and give yourself infinite life or extra money, it's exactly that, and that's what EDR is doing. If we just have a look at the same diagram again, what EDR is going to do is it's going to inject a DLL into your process, and then it's going to hot patch it with a jump. When you call ZW allocate virtual memory, it's actually going to call, it's going to put a jump instruction there to jump to its own DLL and then it can monitor every time that's called inside your process. It will monitor exactly what's going on and determine if it's bad or not. So this all sounds a bit magical to me. I'm not that great with Windows internals. These guys are a bit better, and we've got other people in the office as well who just live and breathe it. But I just want to show it, to show how easy and accessible it actually is. So this is before EDR, and this is just going to use a debugger and a little program that's going to run those API calls so you can see what it looks like, which is a quick GIF. So we're going to set a breakpoint down the bottom. We've already loaded our binary. Set a breakpoint on ZW create thread X, which is create remote threads API call, and you'll see move R10 to RCX. That's what it should look like. However, if we go install Silence on a VM and do exactly the same thing, open up our injector program, put a breakpoint in, jump to that breakpoint, we'll see that now we've actually got a jump to side def 64, which I'll just zoom in for you just now. Basically, this is what it's done. It's hot patched your process, and now it's jumped into their DLL. And it's not only Silence that works like this. There's a lot of different EDRs, and they all do very similar things. This is an example of Sentinel-1 sticking their DLL inside your process. If you actually again look at it, we've now got a jump instruction at ZW create thread X, which is jumping into their DLL so they can monitor what you're doing when you make those calls. But the great thing from our perspective, and bringing back the good times, is actually we own that process. It's our process. They've come into it. They've edited our process. We can just go repatch it and cut them back out. So you can return that code to the old code. So we've got a repatch memory to a jump to the original code. Update the import address table to point to the correct function. Create a stub to carry out the same system calls, which means you never have to call those Windows API calls anyway, or use something like free library to remove interfering DLLs. The bypass on Silence has already been covered before by Hoang View. I hope I say that correctly. Here, so have a look at that. That's a really good one. What we didn't want to do was just show you a demo of what someone else has already been researching. So some stuff we were actually working on yesterday. I'm going to run through a bit of a demo that shows you a before and after. So this is going to be, we've already got implants in POC2. We want to migrate, and Sentinel-1 is going to catch us migrating, and then we're going to go cut it out. So this is us first and foremost, and the GIF is a bit slow, but basically up here, for anyone who's not used POC2, these are two implants that we've already got inside, and we've already bypassed EDR to get our implant. It's running on a box Sentinel-1 with an IE user, and it's running inside PID 2336. I really want to click to make it go faster, but that's not going to work. So inside Process Explorer now, we can go get that PID, we can look at it, and we can see that NetSH is running. And inside NetSH, we'll be able to see the Sentinel-1 DLLs. So they've hooked it. So now when we go back and we want to migrate and we want to use those same API calls, what we should see is Sentinel-1 should catch us and we'll be detected for it. So in POC2, quite simply migrate will migrate you to, you don't have to give it any additional parameters, it will migrate you to another NetSH, I think, by default. And obviously all our commands are going on this side, everything else comes back on this side, so we'll see that the migrate command actually come back in after it checks in. I think we're on a 5-second beacon at the moment as well, so it's just a tad bit slower. So that's it, it's now migrated. We're actually going to get a shell at the moment because Sentinel-1's been installed in detection mode only, not blocking mode, which is also something we take into account when we're doing red teaming, is that if you actually get something in, the blue team might be well onto you at that point, but if it had been blocked, we would know something's going on. So they can silently watch what we're doing. Anyway, right now we've now got an additional implant in. If we jump back to here, you'll actually see down the bottom we've had a threat detected from our migration and when we kicked it off. So there's our threat, we've been detected, the blue team are now onto us, and it won't be long before we're out. A lot of EDR products have actually got isolation capability and things like that as well, so as soon as you've done that, that's you, you're out, machine's isolated and you're out the network. The next one, hopefully we've sped up and it's a bit quicker, but basically this is the same again. We've got an implant here that's running in PID 7056, but this time what we're going to do on the other side is we're going to hook it or unhook it, sorry, we're going to attach it to a debugger. So again, just showing it is definitely NetSH. It has Sentinel-1 DLLs in it. We're going to open up a debugger. We're then going to stop it. We're going to hook that function. And then we're going to modify it back to what the original code looked like. So that's exactly what we're doing now. We're just going to attach to NetSH. There's our breakpoint. We've got the jump instruction that's going off somewhere else that shouldn't be doing that. So we follow it in the disassembler. We're then also going to look at, down here's the dump, which gives you the bytes at that memory address. What we're going to do is, we've already worked out exactly the byte code we're going to put back in there. BC is the syscall specifically for this version of Windows to do ZW create thread X. Once we put that back in, we'll be back to move 10 RCX and move EX BC. That's exactly what it looked like before they had got it, or got their hands on it and modified it and made it. So now what we're going to do is we're going to detach from this. We're going to prove that the implant is still running in memory, so we've not broken it in any way. And then we're going to migrate again. So we'll run a quick PWD just to print the working directory for our implant. That will come back down here and tell us the working directory. We're then going to run migrate. So this is just exactly the same test as last time. We'll successfully migrate. Another shell will come in, as it has now. There it's here. And now when we jump back to our VM, there was no detection because Sentinel-1 just didn't see it. They put hooks in at the very start when you kicked off the process, but they didn't continue to monitor that on an ongoing basis. So they did it in our process, so we just undid it. And I think, now, so I've shown you some things on EDR. Rob's been doing some cool things as well. This is some of the problems we come up against, and we face them on a regular basis. There's sometimes when you're doing this, it's continue cat and mouse in terms of we unhook it, then they start to look at ways to stop you being able to hook it. But there's different ways in which you can play, and Rob's going to cover some additional ones now.
Okay. So as we've just been discussing, as red teamers on our way to the objective, there's certain things that we have to do. We have to migrate. We have to persist on boxes. And, I mean, we just essentially just can't run in memory the whole time. Sorry. So, as you've sort of seen, EDR is getting pretty good at spotting what we're doing. We've found as well that, there's also seems to be a bit of behavioral, well, for want of a better term, behavioral signatures coming along now. So, you're kind of the example Doug gave of the sort of the canonical migration of opening a handle to a process, allocating memory, creating a remote thread. There's other examples too, such as, downloading a file or opening a connection out to the internet, writing a file down, and then executing code. You're probably going to get pinned as being a downloader. Other actions as well, like opening up LSAS and dumping all of your memory. You're probably going to get pinned as Mimikatz. So what can we do? Well, there's a few things realistically. We can learn the detection mechanisms. We can learn what's going on. We can use the live off the land strategy, and we can abuse built-in functionality. Now, some complex engagements that Doug and I have been doing recently, they've required us to kind of look back and sort of look at some functionality in Windows that's been around for a while. And it's basically, we've had to become best mates with COM because most of this functionality is essentially accessible via it. So being that it's a 10 to 15 minute talk, or my section is at least, there's no way in hell that I can possibly begin to describe what it is. James Forshaw did a talk at Infiltrate, I think it was last year. Common 60 minutes, absolutely brilliant. Probably the best kind of talk that I've seen, in a succinct way. That'll get you into the basics. But there's two main takeaways that you can kind of have from this, is that COM is not a language. It's a way for languages to essentially talk to each other. You can build components in one language, and then another language can consume. Also, the way it's implemented, it heavily uses the registry underneath. So as we're kind of going back to, well, we're on our red team, we're sort of landing somewhere. Now, I'd love to say that we have like this massive stash of browser 0 days and that's what we're using to get in, but it's just not the truth. Quite often we'll sort of end up in a process that shouldn't be talking out to the internet, shouldn't be executing code, shouldn't be, you shouldn't have system management automation, loads of different things that it just shouldn't do. So what we need to do then is to move into a process that's, a bit more looks more like what we're doing, so we can try and hide what we're doing. IE is a great candidate because it's installed everywhere, it's quite often open, and it's talking out to the internet. I did a talk last year at SteelCon called Common the Power Thief, which I sort of released a tool, which is an IE post-exploitation. There's a little section on there about actually being able to migrate from one process into IE without using any of the traditional mechanisms. Now, why this is key? Because it breaks the attribution between. You won't have this sort of suspicious parent-child relationship, i.e. you've landed in Word, that's where you're executing code, and then it's suddenly called IE or something else. You haven't sort of seen an open process, you haven't seen anything else. So how does this work? So the key to it is a concept known as junction folders. This was a technique that was leaked in the Vault 7 dumps. Haven't linked to it, of course, but it's out on the internet. Very, very interesting read. It forms the basis of Sandbox Escaper's recent, I think about a week or so ago, the Sandbox Escape out to the medium integrity IE process. Essentially, you can add some registry keys, and then you can build a folder within a certain format that if you navigate to it, it's then going to load a DLL of your choosing within that process. So is there a legitimate use for this? Absolutely. It's a little bit of a hack, but so if you sort of look at the top left-hand corner there, you'll see an icon that looks like a control panel, but it's actually not. What it is, it's a folder that's been named in a particular format. So if you sort of see the middle red box there, it says something like file folder, and then it's got a dot, a squiggly bracket, a GUID, and then a squiggly bracket on the end. Now what that means is, as soon as you navigate to that, Windows will actually then look up that particular value in the registry, which happens to be under HKey classes root, CLS ID, and then the GUID. And then however those registry keys are set up, it'll then essentially load what's there. So in the case of control panel, it'll go and load shell 32 DLL, and that in turn will read how the registry keys out and it'll load the control panel. So can we use this? Absolutely. We can go and create our own. Now, in order to be able to create a HKey classes root, we have to be admin. But thankfully, we don't have to create them there. We can also create them under an HKey current user, which we essentially have access to. So if we wanted to build our own, which we've done here, you'll sort of see in the first screenshot, we have default pointing off to our DLL, which is evil file. Now, the beauty of this is you don't have to call it a .dll or a .exe. It'll just load it whatever. As long as it's kind of got an MZ header or whatever, it's going to get loaded. The second bit just shows some other values that you have to set up there for it to be recognized. So how can we use it? Well, if we can get access to, well, essentially, if there's an IE window that's currently open, we can get a reference to that. And if we can get a reference to that within Chrome, we can then call this method called .navigate_to. Now, .navigate_to takes URLs in a specific format, which is shell, /, squiggly bracket, the GUID, and then the squiggly bracket at the end. Now, if you trigger the navigate on that on IE is going to read that registry key, pick up the DLL, and then load it inside the process. And that's cool. So how do we get a reference to our IE window that's open? Well, thankfully, there's another common class, which is a great one too, called shell windows. And what this allows you to do is enumerate all of the open IE and Explorer and Windows Explorer windows that are essentially currently open. So all we need to do is essentially activate that. There's a Windows property on that, which is an array. We can just loop through all of those, look for which one's the one we want, and then we can call navigate. So as PowerShell's dead, here's an example, and this is it essentially being done in PowerShell. What we first do is build up a GUID, and that just happens to be, so the GUID there is actually a specific one for shell windows. That's actually, you can search for that in the registry. From there, we create a type within .NET from that. We create an instance of it. And then there, we just pick the first one. So we basically just do a zero index. So what this essentially will rely on, there's at least one Internet Explorer window running at this point in time. If you've got just a Explorer window, it's this particular example won't work because it doesn't support Navigate 2. But then what I've also done then is I've built a Junction folder with that GUID. So as soon as you hit Navigate 2 on that will then go and get IE to essentially load that DLL in the process. And then we essentially have no relationship between the two because it's all gone through COM. So is that weaponizable in a way that you might be able to land in an environment? Absolutely. You can actually do this in VBA. The problem with VBA is that there isn't really any easy way to do registry function, to be able to sort of create the registry keys or anything else. But thankfully, it has a concept of platform invoke, just like .NET does, in that you can talk to and call essentially the low-level Win32 APIs. So what I've done there is just essentially defined function prototypes which relate to the actual low-level Win32 APIs, which are all of those. Basically, sort of, you create and set registry keys. Then from there, we've got some more VBA, which just goes through and essentially creates all of the registry keys like they were viewed before. And then we have our final piece of the puzzle, which we create the shell.application. We then go through all of basically loop through the dot windows, look for anything that has a full name of iExplore, and then based on the CLS ID we had, we build up a shell triple colon, a squiggly thing, and then we call navigate, and then that's going to launch our DLL. So, do you have to write just standard native C++ DLLs? Now, I spent about 7 years of my life writing C++, and I'm kind of over it now. I much prefer sort of C#, kind of what I'm known for. And thankfully, yeah, you don't have to, because also as well, not everyone knows C++, and it's quite a massive learning curve. There is a function with .NET called controllable wrappers. Now, these are really, really handy. They allow you to essentially build a .NET object away so it can be consumed from a common-aware language. Absolutely not enough time to go through it in more detail, but there's a really good link on the MSDN on how it works. But essentially, you instantiate your object like you would any other COM. The .NET runtime's then started, the DLL's loaded, it calls the default constructor, and then you can start interacting essentially with your object. So how do we build one? All we really need is basically just a .NET assembly with a class that implements an interface, and then we need to set up some registry keys. An interface is a kind of a very important concept within COM. Essentially, it sets up a binary contract between objects to sort of say, I support this function. So the first thing we have to do is we have to build up our interface. So in this case here, we've just got a namespace of COM registrable. Pretty much everything you need will be in the system.runtime.interop services namespace. But we just have to annotate our interface as COM visible. Have to give it a GUID. We just give it an interface type. For this, we just give interfaces dual. I just go with those. And then we have our main class. What's kind of not shown on here because the constructor is too much code, I would actually have to provide a function definition for that test method, which is defined in the interface. If it didn't do that, then the compiler would break. So what we're essentially doing here is just using, once again, we've got to mark it as COM visible true, give it a GUID. We give it a program ID, so if we do want to create it, we can create it via that name rather than having to use it using GUID. And then from there, so in the constructor, when essentially the DLL loads, we're going to have just a message box just say higher. I've also got like a not slide in the shell code, and that'll run. But this is not going to do too much. So I did say it needs registry keys. So if we then want to be able to use it with the previous technique of actually the Junction folders, we've got to go and essentially record what those registry keys are. So unfortunately, the next GIF I've got, it kind of goes off the process monitor filter too quickly. But I'll just explain what I've done. Is essentially I'm looking for anything that writes to HKey classes root via MS build, because MS build is essentially what's going to go and build and do the registering and everything else. So here we go. So there's my filters. Essentially clean the project. Rebuild it. And then from there, and also, sorry as well, you have, if I did mention, you have to run Visual Studio as admin in order for it to be able to uptake HTTP classes root. So there we can see it's kind of written out. I'll just use jump to and process monitor there. Got to jump straight to the registry key that's been written. And so from there, you can sort of see the code base points out to my DLL. There's a whole bunch of other things that are all set up. Okay, so then if we want to use it in the Junction folder scenario, what have we got to do? Not a hell of a lot, to be honest. I mean, basically, all we have to do is just change HKey classes root to just be HKey current user, and then we can essentially put that into the registry. Very important point is that if you're on Windows 64, you have to import it from a 64-bit process or use the explicit 64-bit registry key. Otherwise, it's going to end up in the Windows 32 node, and it won't appear there when you use regedit, and you'll waste a lot of time looking for it. There's a good write-up just on that link there. So in this example, I've tweaked my Internet Explorer shortcut slightly. So this kind of demonstrates a bit of a persistence mechanism. I'll just wait for this one to answer again to explain it. Should be, yeah. Yeah, so there we go. Just click IE, and that means that the DLL is basically loaded. It's gone and kicked off, and we've got our message box, and let's run all the other code. Then if we go into Process Explorer and then just view the DLLs, we can essentially see that it's loaded. Okay, so remember this script from earlier. Allows you to essentially launch a DLL. Well, we can tweak it slightly. So what happens if we've got an Explorer window open instead? So in this case, we're just assuming we've got a Windows Explorer. In this case here, what we're going to do is just navigate to PowerShell, and we'll see what happens. So here we are in LinkPad, which is my favorite development tool. All I've done is just what I'll do is just launch a PowerShell window. I'll copy that previous script, paste it in, and then we launch another PowerShell window. Now the important point here is the parent process. So there, it's actually launched from Explorer rather than any of the others. So rather than having to mess around with load code from Stack Overflow or anything else, we can just call a couple of COM objects and then boom, we've moved into another one. And I've sort of been having a look at this from an ETW perspective, and I think it kind of gets around the previous detection part. Putting more work into it at the moment. So if we look at this, we can see the second one has essentially been launched from Explorer rather than from LinkPad. And so we've broken the attribution between the processes. Now, the beauty of that also being in COM is you can pretty much port that to anything else, any other language that understands it, i.e., VBA or whatever. So cool. So kind of a summary on EDR. It's not a silver bullet. As you can see, we've got our own bypasses. We've got different ways. It does work for some things well, it doesn't on others. It does give incredible visibility, and there's some very, very good points. But as with everything, as all technology, it's a complementary piece, and it definitely should not be solely relied on. And yeah, we're all about sort of people, process, and technology. And also, as you can see too, this is a constant arms race. So, future predictions.
Quick one, finish up, literally 30 seconds. Sorry, man. Yeah, so just some future predictions. As Rob said, a bit of an over-reliance on EDR. It's not the silver bullet. Customers are focusing all their attention on the endpoints and not actually the critical data. So we're probably going to see a push from that perspective to make sure that's all logged and monitored. A bit of a move to zero trust networks and MFA everywhere. So that's kind of a bit of a prediction. Machine learning, so a lot of investment into people and process. So if you can understand, your processes internally, an attacker isn't going to know those processes. So anytime you avoid those processes, from a behavioral perspective, you can sort of see that and sort of catch people out quite early. think there's going to be a bit of a shift to C2 frameworks using more sort of native C++ code. MSF, could even be revived for red teaming, and OJ is doing quite a bit of work in that space. All standard AV and EDR vendors are starting to adopt AMSI. Not a prediction, but Windows 7 is going to be end of life in January, so just watch that space. Windows 10 has removed .NET V2, so all the PowerShell version 2 stuff is completely gone now in the later versions of Windows 10. And I think lolbas and lolbins, I think, again, they're a finite list, so from an execution perspective, people are sort of veering away from them now because a lot of EDR sort of vendors have got those signatures in place, so it's actually better to move around them and use even like an executable. So it might seem quite simple, but actually that's not on their list of known bad things, so if you're not on that list, then you're probably going to get through. And lastly, just leave you with find a job you enjoy doing and you'll never have to work a day in your life. Thanks very much for listening. We're doing some training at SealCon. Thanks a lot.